How about now? How's everybody doing? Welcome to the stream. I need to shave my face. It's one of those days. Plastic bits first. Thank you very much. How are you doing? Yeah. It's been a while since I've streamed. Been busy. But you know, it do be like that sometimes. I think this works. Things aren't loading. Failed to load module. Off to a great start. But that's okay. Yeah, so we're going to work on some parametric keyboard design today. Gonna make some progress on some custom keyboards that are fully parametric. So let me give you guys a let me update the I'm gonna add an info little command to the title. We're gonna do command info. Hey Thrash and Tony, how you doing? Here is a work in progress website. Okay. Oh my goodness. Matt. Hubert the Mad. I'm trying to juggle things here. Where is this link? There it is. Okay. Okay, command added. So I think if I type info, in theory, it should respond back. Thank you for the sub, Hubert. I really appreciate it. 7 months in total. Wow, that's like a lot. Dude, thank you very much. Yeah, I really appreciate it. I'll staple you to the wall here. And will the cameras work? This is the moment of truth right here. Oh, they work. They work. Well, maybe they don't. But that's okay. Tony, how you been? By the way. When am I going to see you again? Let's try this info thing again. Begin beeping is what it says. I am not going to the Texas meetup because it's too close to Bethany's due date, unfortunately. So what is it, like April 20 something? I have the Discord. Also, I don't have tickets, so March, no. The date, when is it? They don't have them. Meetup info. General info. Yeah, April 27th. It's way too close to be in Texas, so sorry. I wish I could. I was planning on it. But with twins, they could come early and it wouldn't be like a surprise. So, well, it would be a surprise, but I wouldn't be surprised. So, yeah, I'm like super duper bummed that I can't go. Actually, like I'm sorry, honey. I'm in Texas. Good luck with the burst. Where is first redeems? Gonna be a lot more busy too. Yeah. Yes and no. I mean, obviously we'll be busy for like a while. But like I don't know. I feel like you still find time to do stuff that you like to do. Like you still like you just I don't know. Obviously for like the first while like it's going to be wild, but like I think eventually you just prioritize what you like and yeah, maybe next year. Next year is the goal for sure. Okay. So for some reason my command thing isn't working and I think I know why. Let me just check really quick and just give me like a minute because let's see here. If I can fix it, then we're good. I gotta fix it at some point anyways. Yeah, so I don't even have a command. I do have a command. It doesn't do anything. Also, what is this song? Does this work? Nope. Yeah, we have the add command action, but we don't have the actual command. I live 2 minutes away, so I'm definitely going. That's convenient. Yeah. So you know what you should do? Y'all should just come to the Iowa keyboard meetup, April 6th. There's still tickets. That's in a month. Holy cow. Right? Yeah. I should probably send out more info on that sometime. Then you get to, yeah, hopefully they don't come that early. Otherwise, I wouldn't, like, okay, let's say the babies are born like early April. That would be pretty early, but like at the same time as last year. Yeah, I don't know. I could try to go again. I could definitely probably swing that one. Maybe. Ooh. Yeah, I want to see the Bower Light. I haven't seen one yet. I think a year from now would probably be the earliest that I could go to one. But yeah, like let's say like I wouldn't cancel the Iowa keyboard meetup obviously because people have like made travel plans and they've bought tickets and stuff. I would just like designate some people to run it. Like I would just like I don't know. It would have to be a community effort at that point and just cross my fingers that it all goes smoothly. Just good old Iowa nice, like here's the one person in charge, but they're not really in charge. But let's not think about that. Yeah, okay, so this isn't working, so I'm just going to add it to my to-do list and do it later. Put me in charge. Easy. All right. You are the designated survivor. Okay. Oh, I think I know why It's not reading every message. Yeah. I do know why, but I'm not going to fix it. It'd be so easy to fix. Yeah, let's just fix it. That's the thing that I learned sometimes is sometimes you just got to do it. Yeah, let's open this up and let's hope it doesn't screw up my things. But yeah, we're going to be working on a keyboard layout today. I don't know if you guys have seen the layout in the Discord. Twitch message action. Yeah, we want to export. We want to copy this. Can I just copy it? Okay, we're going to add to export. We're going to export. And we're only going to add to export. Dang it. Sorry guys, I'm not paying attention. Export to clipboard. Now we're going to import. Oh, apparently we're going to save as well. We're not going to include that in the import. And we're not going to include that in the import. So it's just that. We're going to import. Twitch message action. Twitch chat message. Yes. Okay. Now things should work if I type in info. No, it's not going to work because I have to change the IP address. All right, let's try this. Hey, there we go. We have commands working and we've got 1, 2, 3, 1, 2, 3. Perfect. Okay. See, sometimes it's just easier to fix it. All right. So let's share my screen. What am I, in a meeting? Guys, I've been working way too much. Oh, man. I haven't streamed in a while. Let me just hop on Teams here and share my screen. It's been too long. It's been way too long. Okay. Let me just switch scenes to the middle desktop. So, for those that are unaware, I have set up a parametric model so that I can generate keyboards with a given layout. Okay? So all I do is put in the layout information and it generates the keyboard model. The only thing that I have to really do is like some basic PCB design, and that's it. So the goal is you can turn any keyboard layout into something real. I'll do all the design, the testing, the firmware, and the shipping. A unique keyboard kit delivered in 1 to 4 months. So the idea is you paste in your layout from the keyboard layout editor, which of course I just accidentally went to here. So you use a preset. Let's do this. You take your data, you put it in here, bippity boppity. There's your data. The preview would show, which is currently a work in progress. You would select how many units that you would like. Right now, I've only got the math set up for 5 units, so all the others are grayed out. And then these numbers aren't fully updating yet, but then you select what kind of keyboard type you want. So if you want a keyboard type of rectangular, which is what all of these are, you would select that. I don't have a non-rectangular parametric model right now, or a rectangular split, or any of these, but those will come soon. TM, maybe. Trademark. Solder to hot swap. So the price will update, and then the encoder count. There'll also be like more options as we go through this. So there'll be like a more details button, which will explain some of the pricing, and then get an official quote where you click this, you put in your email, and then you click submit, and I get that information, and that's where the automation starts. So some of the things that I want to automate is I want to automate quote generation, so that when somebody submits a quote, the only thing I have to do is review it myself, make sure it's good, and then press a button or whatever, and then it automatically shares it with them. I want to make it so the model's already parametrically designed, so I just have to import, it takes like an hour. Actually, I generated all 4 of these models in under an hour for these layouts. So it takes like 15 minutes to make a keyboard design, the bulk of the design. So that's already done. The next step is to use layout information to place the circuit, the footprints of the circuit. The next step is to automate more of the circuit board production, or design, not production. Currently, the circuit board design is not automated at all, and there are some tools out there that that I could do that. So I would put in the layout information, and then it would generate like 90% of the circuit board, and then I just have to do things to finish it off. Hopefully, like, under like an hour or whatever. Like that, I feel like that's good enough. Especially when, like, you're paying up front. Like, I don't mind putting in time to make a keyboard. Like, they're paying for it, so I'm gonna put in the time, right? And if I can lower the time that it takes, then I can make more money, or I can save the customer money. But I think for like a layout of your choosing, of like any choice, basically, to a degree, getting an instant quote and like it's comparable. So like a 60% would be around like $150 per board. So like this pricing here is, let me look. This pricing, and we can actually look at some of the pricing stuff, because I do need to possibly change a few things. So like, here's some of my variables. Let's okay, that's not what I want. Okay, we're gonna run a development server of this. Okay, so this is the development server. So you guys can't see this at all. How do I zoom in? Okay. So, like right here, width and height. So like, let's do a 60%. Let's do like I think this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's do 15U, or yeah, 15, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Keyboard is 15 units wide, as 60%. Height is 5. Key count, 60. Units, 5. Pin count is going to be, typically it's going to be width and height, so 20. Key area is going to be, this is all calculated. The rest, so the only parameters that like really need for this calculation is this. So let's check it out. So like, here's the pricing for a 60%. So an FR4 kit would be $123 per unit, and then with, if you want the 3D printed case with it. So like, here's the kit. Here's the same kit with the 3D printed case. It'd be $171. You look solid. Yeah, I would agree with beige. Beige. Hello. Hello, Koala Gone Wild. Good to see you. So yeah, like, you know, 5 units for $617. Like, that's pretty good. I think it's a solid pricing, and that factors in like, looks like beige just wasted all of his moolahs. I changed a lot of things. I like redid everything, so not everything works. Let me just copy that down so that should we do pics? Yeah. Let me just copy that down to my to-do list. Beige. All right. Sorry about that, beige. Those points are mine now. All right. So yeah, I think it's a good price, like, for what it is. The key though is to like make it a solid enough process. My current, big scam. My current process right now, I've factored in, let's see here. My engineering cost per hour is $35 an hour. And then let's see here. My current, depending on my engineering, it's variable depending on how big the keyboard is. Let's see here. There's the key area, the circuit board cost. The engineering hours is 7 plus the key count times 10 plus 10% of the key count is the engineering hours. Then the engineering cost is the hours times the price per hour. So like every keyboard that I design is a minimum of 7 hours currently, plus like bigger keyboards take a little bit longer. That's how I factored it in. Architecture hours, that's like all. Are you pulling a joke on me, or am I just confused? So that's what we're doing. If you want to take a look at the website right now, picatcustomboards.netlify. That's not going to be the final address or anything like that. This is just a work in progress site. This site is very work in progress. None of the calculations are actually working. I've yet to like actually read the layout and preview it and do that. But this is what it's going to like look like. That's the goal, at least. So anyways, let's actually do it. So hopefully we can, so we have a keyboard layout to do. Like I said, my estimated time is 7 hours plus 10% of the key count. So according to, and obviously, like, let me show you guys the layout that we're doing. So this was, we did like a little bit of a contest. Oh my goodness, who put this guy in here? What in the? Oh no. But yeah, if somebody wanted to make that, like, I wouldn't have a choice. I mean, I could say no, but yeah, that was Chaos. Chaos has submitted some pretty unique stuff. So this is the layout that we're gonna go for. This is a war crime. Yeah, honestly, like, Look at this. What's this? How do you, this is bad. Well, it's not bad. No offense to Chaos, but it's not my favorite. Let's just put it that way. I hope you know that this is not a good layout. Anyways, let's get rid of that because my eyes hurt looking at it. So this is the layout that, let's see here. Ruby C won. Ruby C won the contest, and this is the layout that he chose. There was also what I actually... Okay, this is the actual layout, the gist of it. It's an F front. I'll take two. Okay. So originally he had it like this. Yeah. Originally he had it like this. And I think what we're going to do is we're going to... So I did get permission to modify it a little bit. And that'll be like part of the process. And the reason why, like, you get a quote, you have to get request an official quote, is because there's some layouts that I like just can't do. I can't put an LED. For one, I haven't factored in LED panels, so this is just. This is a favor. This LED panel. Oh, it's Jack. We good. Yeah. So, you know, obviously, like, there'll be like an option for like if somebody uses the website and they request a quote and they put a layout in that has, and they put like a LED panel on there, I'm gonna modify the quote. So it just, you know, it's, the final say is still up to me and what I think is doable, but like it's mostly still automated. It like gets the ball rolling at least. So for this, if somebody were to submit this layout and they see this LED panel and I see this LED panel here, I would immediately add like 2 extra engineering hours onto it. So Jack can make anything happen. We keep hearing your disc. Oh, I thought I turned like off my desktop sounds. Like you should only hear Spotify. But I can also just turn on streamer mode. Thank you. Streamer mode. My bad. Thank you, Ava. Okay. So originally, this LED panel, this needs to change. Unfortunately, we're gonna have to do, and I'll need to figure out what and how big an LED panel actually is. My guess is it's actually more like this. 1x2. So this will work. We can do a knob here. This is all good. Personally, I'm not a fan of this shift, but it's not my layout. So originally it was, I don't even remember what it originally was. I think it was, I moved it over to here. So that, the reason why we moved up to here is because this is one continuous piece across here. There's no islands, right? But I think I'm going to challenge myself a little bit. And we're going to do this. We're going to make it either that or that. See, it just doesn't make sense to like do like let's do this. Yeah. So I'm going to challenge myself a little bit because I do know people will make islands and I want to be able to support that. So we're going to update the parametric model. How are you going to attach it? See, it's a very good question. I've got an idea. It is. It's going to get a little weird. Yeah, there's going to be a floating blocker here. And then hopefully this won't be an issue with like, yeah, I think it'll be fine. Like it's not going to be connected here, but that's okay. Like it'll still print just fine. And yeah. Personally, nah, it's okay. This is fine. This is fine. I don't know what's going on. Whoa, I didn't even realize the enter key is like down here. Oh, wait. Where's the 0? Oh, the 0 key's up here. Ah. Like if you secured the floating blocker under the PCB assembly, it could still look all right. Yes. So the blocker is actually going to secure to the plate. The blocker is going to secure to the plate. So let's go ahead and just start with this. So we do need to do a few housekeeping things. Well, we can do that. We can do that later. Let's save this. Yeah, this is the Ruby C180. Yeah, okay. I'm also going to sign in. Because I actually want to save it. Let's blur. Of course, my blur does not work. That's good to know. Yay, it doesn't want to work. Alright, you guys can just look at my face. We're still good on stream, like we haven't dropped any frames or anything like that. Okay. Sign in with GitHub, please. So recently I recently as in today, this morning, I got a new router. I don't think this is it. There's the reason why it's doing this, but oh, there it goes. Sign in. Okay, now I gotta say yes, it's me. Approve. Okay. Add passkey. Ask me later. What's the point of that? Isn't that just what a password is? New networking gear is always sweaty for a bit. Sweaty? What are you talking about? Sweaty? Okay, I do need to put a note here. What? Okay. Every time I get something new in my network, I always stress for a bit over whether or not everything is still going to work. Okay. Yeah. So, all right. Or if I'm going to have to delve into hours and hours of diagnostics. I see. Okay. So, ooh, excuse me. We're back. Here's the layout. We saved it, the Ruby C180. So then what we do is we generate the, actually, let's go ahead and open up the model. And while we're opening up the model, we're going to use the Kibio plate generator. And eventually I'm going to make my own plate generator, just because I don't want to have to rely on Kibio for it. But they've got this awesome thing here, so we're just going to use it for now. So this, before we actually do that, we do need to, we need to modify the layout a little bit more. Notchdom wants this bottom layout. This bottom layout option. So what that is this a 7U properties? No. Okay, so he wants a 7U support. I think we can just do this for fun. Let's add in a spacebar. Make it 7U. Delete. Or if I'm gonna have to delve into hours and hours of diagnostics, yeah. It was surprisingly pretty easy to set up. Okay, so that key, this alt key is moved over here. And then we've got this control key. Okay, this is fine. So there's just like a, yeah, and I'm actually gonna do another, we're just gonna do this to make it simple. This is 1.25, let's do 1.5. Let's do a standard bottom row. Just because people are gonna want it. So we want this layout. Oh wait, okay. I did this wrong. Wait, what? Somehow that got, whoa, why is that? What the? Oh, it's a little bit bigger than what it should be. That's why. Yeah, we're gonna do this. Okay. So let's take the raw data. Let's generate our plate. And then we want to, what we want to do is we want to combine overlapping layers. So let's download the DXF. And we want to make a new project. Let's call this the Ruby C 180. So this is going to be the plate. Then what we do is we do our, oh, I like to do stabilizer cutouts. I like to do 3mm plates. Yeah. Okay, and then what we do is we do a keycap outline with a kerf of -1. So that gets us our outline. See that? So KB outline. Okay. Then let's go over to our model. Let's open up our parameterized keyboard. Open the latest revision, and let's copy that into parameterized keyboards, new folder, Ruby C 180, copy. Let's rename this to the Ruby C180. Yeah, let's do that. Open this up. All right, so next step is to check the layout. We are 1, 2, 3, 4, 5, 6 units tall. So let's change the height. Okay, there's the height. And we also need to, I think this is the, yeah. So I like to go right here. Okay. The height, and then what we need is the width. So that would be 1, well, okay, this key is on X18.5, and this is on X0, so it's 19.5. So we are 19.5. And we need to verify, okay, it looks like this is enough holes. We could maybe add one more, but I think this is good, like all around. What do you guys think? I think we could do 6. Does 6 look better or worse? I think I'm gonna go with 5. 5 holes on the top and bottom. 1, 2, 3, 4, 5. Yeah. Okay, and we also need to figure out where our microcontroller is gonna go. So we're gonna put it right. Do we put it there? We're gonna put it right. We could put it right over F9, and like we could put it here, here. Let's put it over the numlock and insert key. I think that makes the most sense. What do you guys think? Yes? No? I defer to the experts. Okay. All right. Shy, you're, yeah. I mean, we'll put it here. So this is going to be on position 16.5. So the middle position of that is going to be 17. So then what we need to do is we need to input that into our model. Turtle Cat! MCU unit center left, 17. So that's going to bring that all the way over there. Hey. Kev! Yes! Oh! We're making keyboards. Thank you, Turtle. Hi, I'm Superior Kev. That is very true. All right, now what we do is we need to show the origin. We need to create a sketch. we're going to insert the DXF for the plate. So that's going to be under projects, Ruby C180. We're going to do the plate first. Okay. Then we're also going to, we're going to finish the sketch. We're going to create a sketch. We're also going to insert the outline. You can see it's like already lined up there. All right, let's finish that sketch. So now what we do, so let's delete these two, because these are already, for some reason I like can't delete them. I have to like, this is weird. Why is Fusion 360 being weird? Yeah, it's like dropping down under my screen. Why do you do that? Okay. Yeah, it's like dropping down underneath it. Okay, so we're going to delete those. Then what we're going to do is we're going to, also we need to hide the, let's hide this sketch. This is the plate sketch, the plate reference sketch. No. KB plate, and then this is the KB outline. So let's hide the outline first. Let's hide everything except for the plate. So we're going to isolate. Then we select all of this, except for the origin. We don't want the origin. Select all that. Extrude through the plate. Bam. There's our plate. Then we do the same thing with the printed top and the outline. So we just extrude this through. And there's the top. Now there's the island that we'll have to figure out. So we're going to update the model for this. So yeah, what we are going to do is we are going to delete these sketches here. Oh, apparently the bezel outline is referenced. Okay, well, we're just going to keep it then. But we're going to hide it. So now let's see here. Let's get the back in there. Let's do get all the different components going. So yeah, there's the thing. Where's, oh, why is the PCB? Oh, that's because we have yet to finish the construction of it. So then I just slide this timeline over. And then there we go. There's the final construction of the thing. Are we still, yeah, we're still doing that. Okay, well, I'll just do that if I have to. So yeah, we can remove this back plate and you can see the innards, the controller is going to go right there. Let's go ahead and, okay. How does this work? Okay, so it goes right up next to it. Yeah, that makes sense. Okay. Sorry, I'm like moving this around a lot. I probably shouldn't. What next? So, how do we secure this island? Where did you learn how to do this? Well, I went to school for I have a manufacturing engineering degree. But I mean, I really learned this all just by practice. I mean, I've been doing CAD for like 8 years now. So you just kind of make stuff, and like if I was to go back and look at some of my earliest models that I ever made, I'd cringe. But, you know, it worked at the time, so this is probably one of my most advanced models I've made so far. So how do we secure this? My thought is we do need... Also, is this the only... That's the printed top? Printed top 1. Okay, there's 2 printed tops now because it's got the thing. So I think... Yeah. School plus self-training. Yeah, I think school... It's like, you don't want to underestimate school because you learn so much from, like... You learn the right way to do things. You learn the right way to do things, but then when you practice... You practice and you do it like outside of school, you learn the practical way to do things. And so when you combine like the practical way and the right way, you find this sweet little middle ground. Yeah, that's what I would say. Okay, so I think what I want to do, let's do this. We need to do this immediately after we generate the plate, which is right here. Yeah, let's do it right here. So we need to input a parameter. Let's create a parameter called island screw. Island screw, island bolt, height. And it's just a non-united unit, no units. So for this case, the height is going to be... Where's my window? The height is going to be 2. 1 half, 1.5. It's going to be right here, 1.5. So 1.5. And then let's create another called island bolt width. And that's going to be... This is partly why I'm doing this. This is because I want to develop this model more. So that's like what? Like we said keyboards are 60% are 14 across. 15. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 across is right here. So that's an 1/8 and a half. Is it? Dude, I don't know. Where's the width of that? 15. It looks like it's... Oh, it's... Yeah, it's like in the middle of a... Okay, so it's 14.5 minus an 1/8. 14.5, either minus an 1/8 or a 16th of a unit. So let's just make it easy and let's just do 14.5. And that way, because it doesn't need to be complicated. Okay, then what we do is let's get my origin. Let's create a sketch. Create a sketch. And it's going to be we're going to make... Let's just draw a line. Construction. Let's go... shoot. We want it from the... Okay. What we want is... Do we actually measure from the top left? That makes sense. Hey, move. Let's measure from the top left. Yeah. So if we're measuring from the top right, it's actually 1, 2, 3, 4.5 units. So let's change our parameter here. Oh, and this needs to be non-millimeters. This needs to be no units. There. So let's go 4.5. Make it a construction line, and we'll go down and then over. So in theory, this line will be 19.05 times island bolt height. Yeah, look at that. It's right in the center. And then the width of it is going to be 19.05 times island bolt width. And that was totally the wrong number. 19. What? 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 It's like all the way over here. Why is it all the way over there? $19.05 times. Oh, it's like not, it hasn't updated the parameter. Still thinks that this is a, let's get rid of the island bolt width thing. No units. 14.05. There we go. Okay, so you can see it's like, it's not quite right. So we're just gonna find the center manually. So let's do like 2.5. Now, so it's in between 2.5 and 5. Which would be 3.5. 3.75. Ah. So there it is. There's the center. Okay, and then what we do is we let's get rid of the top. So let's modify, let's edit the sketch. So what we need is we need a circle. This is going to be the bolt. So it's going to be an M3. It's going to be the bolt hole. Then we want to key it a little bit. So let's make it let's key the bolt hole. So let's do 6 millimeters across, and then let's do 1.5 millimeters wide. Okay, and then what we need is we need a second circle for the bolt head for the circuit board. So this is, I think 8 is probably good. Let's see here, let's check McMaster. That's not what I want. That's going to show my address. Socket head, M3 bolt. Check the product detail. It's going to be 5.5. So 8 would be plenty. Let's go with 6. Okay. So then let's go ahead and start to extrude, and let's select this profile this profile, this profile, this profile, and this profile. I'll actually not do those because that makes it interesting. And then, so we cut that, cut the plate. And then what we do is we also select, we extrude and we select all of these profiles. And we go all the way through the circuit board. There we go. We have our first hole in the board. So we should be able to like print a little block that fits in there. And this needs to be more than M3. This needs to be like 3.5. Yeah. So now, oh, and then the last step is to extrude into the actual material. Let's get our plates. Let's do that. So we do need another circle here. That is 3. Yes, I've looked at it. Yeah, it's not. I mean, it's not mine. That's the problem. I think I know what you're talking about. It's like a parametric way to design split keyboards, right? There's like a whole website that lets you generate like the plates and the cases and the. Yeah, it uses like a different, but certainly focused. Well, not just, but yeah, it's focused on ergonomics. I know that, but like, yeah, the layouts are. It's a different defined layout, typically. Yeah, I think I know what you're talking about. It uses like a layout editor format that's like not the same as like this standard. If you want to say it's standard. Made a 60% plate in it. Yeah. Parametric design is really fun. I do agree. All right, so then what we're gonna do is extrude that to this, then offset of 2 millimeters. Let's do -2, yeah. We want to cut just the printed plate top, yeah. So then we should be able to, oh, and then we have to key in one last thing. We actually need to create the key part of it. I guess we could do like a cross. Or the key could be like much bigger. Yeah, the key could be much bigger. I'm just worried about printability. Let's make this 2. And then let's make this not 3.5, but like 3.2. 3.1. Let's give ourselves a little bit more tolerance. 3.15. So, yeah, okay. So then what we're going to do is we're going to do a... Let's just edit. Just... Let's do this again. And we're just going to do a tolerance of 0.5. That's huge. This can be adjusted pretty easily later. Like, it's not the whole keyboard, so... 0 point. That's not 0.3. That's what am I measuring? Okay. So then let's extrude this shape up into the that. Oh, I didn't want new body. Shoot. Distance to object. Join. Why can't you join it? Give me the join. No. Why is it not joining? Probably because it's hidden. What I need to do is just hide like all these back plates and the circuit board. Yeah. And then let's go to the printed top. And we're going to extrude to this object. So there we go. And then we can join. So now this is our keyed blocker right here. Okay. And then what we can do is we can, let's say we don't want a keyed blocker. Let's say our circuit board doesn't require one, or our thing doesn't require one. What we do is we just like change our, oh, I think my camera just overheated. Yep, it did. We can just change this to like negative. And we'll get a bunch of errors, but you know, it's not gonna do anything, if that makes sense. Like it'll just be like, it can't extrude. So, all right, let me fix my camera. I know why it's doing it. It's doing it because it's overheating, which is unfortunate. But I do have a fan that I can use to blow air onto it. Hopefully that fixes something. Hopefully it stays on. Okay, so we've got that. I think we're basically done with the design, like the final design. I mean, for the circuit board at least. Or not the circuit board, for the keyboard. Like this is it. The last part remaining is the circuit board, and that's it. So what was that? How long have we been streaming? An hour and 15 minutes? And I would say a good portion of that was me explaining how to do, like, explaining things. So I would estimate total time to make a model is like 15 minutes. You know, if it's like built well. Oh, so we're not actually done. We still need to, we basically need to do the same thing, but for a knob. For a knob, and then we also need to do the same thing for the LED. So we need to do a knob width and height and an LED width and height. And we basically need to do the exact same thing that we did for this island. So, yeah. And the LED one is going to be a little bit tricky because I don't know. It's not like width and height. It's more of an X and Y, but I don't know. Maybe let's start with the knob because I know what the knob will do. Okay. Let's actually just use the same sketch here. So we want to create a parameter. It's going to be the knob1 x. Yeah, this is more descriptive. So that's going to be, according to our layout, knob1x is going to be about, okay, let's not open that. It's not, it's just, this would be 15, half, a quarter, and half. So 15 and 15.75. Okay. We want a knob one size, knob one diameter, and that's going to be 1 unit. We're going to want knob 1y. That is going to be 0.5. Okay. I think that's all the information we need. Okay, so let's go down from here. And that's going to be knob 1y times 19.05. And then let's go over this way, which is going to be knob 1x times 19.05. And that looks to me like it's in the center. Yep. Then we want our diameter, which is actually going to be, how do I want to do this equation? Knob 1 diameter. I mean, we could do the exact diameter. So that's 19.05. However, I don't think that tolerance is right. Let me go grab some calipers and measure some 1U knobs because I don't know what those are off the top of my head. I might auto tracker, but so this is coming out to 17.1 diameter. So 19.5 would actually be pretty darn good for 3D print. Yeah, let's just stick with that. Then it's like uniform and it looks clean, you know? Because it like matches up with the edges. It matches up with the edges right here. Kind of. Maybe not quite. Actually would be, the kerf would be one more to match. It would actually be 20.5 to match. Yeah, let's do that. Then it matches. Okay. So then what we need to do is we need to extrude. So extrude that profile all the way up to here. Okay. And I totally just cut the plate as well. So let's not do that. So edit the sketch. The plate needs to be, I believe it's a 7mm hole. I gotta pull up the my original. I gotta pull up a different project for this. Let's do the long boy. Long boy plate. So this right here. Of course. Of course. All right, let's just measure. So this is 7.3 diameter. Oh yeah, this ain't gonna work. 7.3 diameter. Let's just go with the original Picatinny macro pad top plate bent. Okay. 7.3. Yeah, so we just need to remember this. Just slide this over here. All right, so 7.3. And then it kind of depends how the knob is positioned for where this hole should go. So let's just do 4 holes, because then I don't have to worry about it. So let's go out there, out there, out there, out there. Okay, and let's make all of these the same. Equal, and let's make all of these the same. Okay. Then this distance is all going to be the same of 6.7, 6.875. Okay. Width is going to be 1.5. Oh, that's already driven. And set 2.75. All right, so there's our holes. Let's get rid of the top, the printed top section. Oh, so this already has a a thing. So when I extrude this out, I don't want to include this one. There. Select all of these profiles. Let's extrude to the surface. Okay, so there's our plate. And then let's go ahead and mark the center point of the encoder on the PCB. So what we're going to do is we're just going to create another. Let's just extrude this hole down through to the circuit board. Then we can know the center point for it. All right. So we've got that. What else? Oh. Where's my encoder thing? Why is it not, okay. So let's get rid of, hide the plate, hide the PCB. We want to extrude this all the way through to the top. There we go. So now, yeah, so we've got our knob here. There's that. It's looking good. How do I do an encoder? That is the question. So really an encoder is going to have, or not an encoder. How do I do an OLED? I'm going to think about that, and I'm going to go to the bathroom, and yeah, I'm going to think on this. So I will be back. Apparently it decided to do my top. There we go. So let me grab an encoder really quick and a few other things. So plug in my camera here. All right. So we've got our camera going. So this is the sketchy top plate. This is actually an acrylic vert design, but I've redesigned it to be 3D printed. This actually worked pretty well. It had two displays on it. So what I'm gonna do is I'm gonna use this as a measurement. So yeah. So what we're gonna do, first of all, this sketch right here, we need to not extrude these as well. Okay. All right, let's create a LED. Yeah, okay. Let's do an LED. Let's do vertical. Now, okay, we're only going to support one LED, so let's make this count. LED X, no, not LED, OLED X, and that's going to be no units. And so that expression is also, it's the same as, I think it's 15.75 is what we had down here. Yeah, 15.75. And then we want OLED Y, no units. And from the top, I believe, it doesn't really matter exactly where, but I think like center, put it right there. So that's 1, 2.5 centered. 2.5. That makes it all nice and neat. 2.5. Okay. Then what we want to do is let's do OLED width. Let's do OLED width default. And that is going to be the width of the OLED. What is that going to be? 12 point, let's do 13. Maybe, I don't know. Let's do 15.5. 15.5. 15.5 millimeters. And then what we want is we want OLED height default. And that is going to be 40 millimeters. Matt! I put in your weird layout in the bottom. Okay, then what we're going to do is we're going to do actual OLED width. And it's just going to be, it's going to be the OLED width default. And then we're going to do actual OLED height. And that is going to be the OLED height. That way, if our OLED is rotated 90 degrees, all I have to do is switch these two parameters around. I just have to change which width uses the default, and then it's switched. The whole thing. It's flipped 90. It'll be, because in this case, our OLED is a vertical OLED. But let's say somebody wants to do a horizontal OLED. There you go. Then you just put it in different. So, yeah. Now what we do is let's go back to this mega sketch. And let's draw a line coming down. And this is going to be the OLED X times 19.05. Let's actually do that again. OLED X. No, it needs to be Y. That's why I couldn't see it. Gosh dang it. No. Matt, how have you been? OLED Y times 19.05. I feel like I just screwed that up. I typed 19.0.05. How many times does it take me to OLED Y times 19.05? There we go. Jeez. Good. All right. Well, I'm glad to hear. X times 19.05. All right. Then what we need to do is we need to cut out our thing, which is going to be the OLED actual OLED width and the actual OLED height. Okay. And then let's just make this super simple. Okay, the width. So this is going to be, oh, come on. I gotta do the same thing. Yeah, I gotta rotate this as well. Honestly, what I might do is I might just like, Let's do OLED width. Actual OLED width minus. What does minus 10 do? What does that put that at? 5. So let's do minus 6. 9.5, is that what I want? I want 8.75 minus. Okay. The width is going to change. If the width changes, though, then yeah, dang it. Okay. So I got to do the same exact thing for. I got to do the same exact thing for this. Oh, wait. No. Width default, height default. The width is going to be the default. I just need to make a parameter. I needed to use this differently. So, okay. So I just need to do actual OLED. No, that. So I just switched these around, and the width and the height is changed. Yeah, like if I switch this around, if I do this to height default, and I change this to width default, I hit OK, and I go back to my sketch. Apparently my computer is being weird. Yeah, so now it's different. So this width actually needs to now be height minus height offset. Okay, we can do this. Inner height offset. How do I do this? How do I do this? I wish I could just make it uniform all the way around. Let's do inner width. And that's going to be the actual width minus Let's just say 10. I don't know. I'll just have to document this. So all right. So these need to be switched back. So if I wanted to make this, to move this around, what I might have to do is I might have to switch these basically subtraction things. Is kind of what I'm getting at here. So this will be the inner width. And then this will be the inner height. So obviously that inner width needs to change a little bit. Yeah, inner width needs to be minus 6.75. And this one needs to be like minus 10. So that it's 30. Apparently this one is 25.6. So it needs to be okay. So now what we do is we need to extrude get rid of the plate. Get rid of the back, get rid of the PCB, get rid of the back plate. So we're going to extrude this to this surface. We're going to offset it by minus, what is this, 2? Dude, I can't tell. Oh, duh. 2.5. And then let's extrude this to this surface. So in theory, that should work. And then let's do a let's edit this sketch and let's do a square. So this will be an OLED square. And then this square will extrude into the circuit board. And then we also need to extrude this profile and this profile through the plate, as well as that profile. There we go. So now we have our OLED. We go all the way across and we enable everything. I think we are fully designed. Yeah. So yeah, I think we're gonna leave it at this for today. I want to play some Helldivers tonight. So I think we're gonna leave it at this today, but we've been streaming for like 2 hours. So I would say like, you know, I would estimate an hour is the total time it takes for me to get to this point. I spent about 30 minutes explaining it and about 30 minutes trying to figure out how to do the model. I think at most, I would say an hour. Because I'm sure I'll run into things for a while where like just doesn't quite work right. So this will make it so that, yeah, I can estimate. Very cool to see the process. Yeah. So should we like try, well, I don't know. Like, let's say we want to move this up. Let's say, let's switch here. Let's do this. Let's switch the encoder and the OLED around. So just as a experiment. So this is going to go up here. This is going to go down here. Let's put it right there. Okay, so the knob is going to be 1, 2, 3, 4, 3 and 7/5. 7/5. Ha! 3 and 3/4. No, 3 and 1/4. Okay. The knob is going to be 3 and 1/4, and the panel is going to be 1 and a 1/4. So, let's see your knob Y is 3.25, and OLED Y is going to be 1.25. There. So there we go. So now it's all there, and you know, we've got the plate set up. The plate's good. Let's get rid of this block too. So we've got our keyed there. Not encoder hole for any orientation. And then we've got our hole for the actual to get the OLED through. And we get rid of the plate, and we've got our mark for. This is going to be just a hole for the screw. This is going to be a mark on the for the circuit board, so I can know where to put the encoder footprint. And then this will be. I'll have to make an OLED footprint with the center in there. And then you can see this cutout here. This is to help place this the microcontroller. So yeah, and then let's say we don't want any of that. Let's just say we want. Eventually, what I'll do is I'll have another knob. I'll have like knob 2 as well. So. Okay, what was it before? .5, and this is like 2.75, I think. Let's see. Yeah, that looks good to me. And like visually I can see, okay, that doesn't look quite right, actually. So I think it's 2.25. That's, no, it's more 2.5. Yeah, that's like in the center there, which makes sense because it's like right in the center of these three keys. Yeah, that's the center. All right, so cool. All right, let's do a little bit of planning for hold on, somebody mentioned me. All right, I think we're ready. I do kind of want to make a bit of a checklist, but I'll probably do that offline. I do want to, let's review this though. So what we need to do for, we're going to ignore, hey, Nitram. So on the layout, we're going to ignore the middle key. Well, let's just see how this works. Where's my knob key? Knob. Minus numlock minus plus. We've got LED panel. Oh, I see. Okay, it's just like a new line is what they do. So they do that, then new line, then that. So if I was to like get rid of this, it would just all be right there. But how do we dictate? What does A2 do? Trying to figure out how, and you can't see this, of course. How does it know to use the left center legend? Is it like, what if I do A5? Oh, okay, so this is A5. So now what if I did A6? If I did knob, what if I did testing? Yeah, see, then it just goes test. It just skips over. So what I need to do is let's just do knob. Okay, so we're only gonna look at the top legend. We're gonna look at the top legend. So knob needs, so what I want to do is I want to standardize what stuff looks like. Like, how do you build a layout so that it makes my job easier? And then because ultimately the goal is to use this data for as many processes as I possibly can. So I want to define what this data needs to be. So if I want an encoder in my keyboard, what do I need to put in my layout so that all of my programs can read this well and know that, hey, there's a knob there, there's an encoder there. So I think I'm going to use the keyword knob, all capital. I mean, it's not really the technical term, but I don't know. I like knob. Knob, and then I think what I want to do is I want to make it so that knobs need to be half width as well. That way, if I accidentally, well, see, then you can't center it super well. Well, yeah, you kind of can. It doesn't like look center though. What if we just did an E? Well, the problem is no, let's not do. The hard part is we want to represent the actual width of the. Like we want to make sure that when people build the layout, that they don't accidentally like build it wrong. Like we don't want them to put a knob too close to a key, right? So I think, and I also don't want to accidentally put a knob too close to the key. So it makes sense to put the key to the width of the size of the knob. So let's do that. And then like I also have knobs that are 1.25. So like let's say 1.25. Then you kind of know like, okay, what width do you need? So like I could put that in the center. If we wanted bigger knobs for this keyboard, we could. But we're not going to. Okay, and then this is going to be, we're going to do OLED for that. And then the OLED needs to be, how big does the OLED? Is 1x2 is probably good. How many units is this OLED actually? Comfortably, it's going to be about 41 millimeters, which is more than 2 units. It's about 2.25. So OLEDs need to be about 1 to 2.25. So then this needs to be 1.7. No. This needs to be let me just drop this down by 1.25. There. So, yeah. So 1.25. This is kind of Eka. It's been ages. How you be? Yeah, I've been good. Yeah, I agree. It has been ages. Yeah, so a key labeled with OLED and it's 1 and 2.25, that'll work. What happens if I copy this? What is in my clipboard? Is it actually, no, it doesn't do anything in my clipboard. That's a bummer. Okay. Yeah, I think this will work. So save that. What are we working on? I'm working on parametric keyboard design. So another thing that we'll want to do is, let's go with projects, Ruby C. So what I'll end up doing is I'll create a Python program that essentially lets me, it just like is generating. It generates a new project. So, but one of these things is going to be a text document. It's going to be parameters.environment. Banatech, a parameters.environment. And so this, we're going to open this up. Let's do a new window. Open that up. So an environment file. I don't want to look up one sample. So like, okay, it's like all capital, and then it's like equals for the parameters. Yeah. Okay. So we're gonna do keyboard width. That's gonna be a parameter. Keyboard height. That's gonna be a parameter. We're gonna want encoder 1. We're getting encoder 1 X. That's going to be a parameter. Encoder 1 Y. OLED X. OLED Y. What else are my parameters for generating it? For like everything that I would need to know. Like as an input to automate this. Oh, we want encoder 1 size. Why not use a JSON file and have your script convert that to a dictionary? Yeah, I could just, that works too. I think the reason why I want to use a parameter file is just because it's like it's a little easier to read. And I don't need like a whole dictionary of stuff. Like I just need, like I think this is all I really need. And I know I'm not being consistent. Let's do there. What else do I need? Width, height. Oh, we want island. We want an island spot. Not that it like really matters too much, because some of these I'm not even gonna worry. Top. We're just gonna call it island. We're gonna want the MCU X, and that's it. Oh, we want keyboard width, keyboard height. We want the top. So okay. Let me show you guys. This is why I'm now I'm remembering why I'm even doing this. So it's hard to see, so I'm going to read these out. So I've got unit width, unit height. We've got Because I guess a goal of mine is to actually generate the picking list as well. Because I'd like to make it so that, like if Bethany wants to help me out with like fulfilling orders, she knows what inventory to include in an order. So there's no like, and then also for me, because if I'm gonna do like 10 of these, or the more I do of these, I don't want to like look up how many how many screws do I need, you know, how many of this size of screw do I need, how many of, you know, what's your, I don't know. So I want to have like a one file that I input as much input as I can. Then that way I always reference that file. Like when I first start the project, I fill out this file. Then I can just reference that throughout the whole process. That way I don't ever have any conflicts of like naming or, you know, so like firmware name. Like the firmware name needs to match the keyboard name, and the PCB name needs to match the keyboard name. And, you know, if I have holes, I do, yeah. So I've got like this like hole size. I've got, what is this? Horizontal hole count and a vertical hole count. Actually, set that to 2. Well, yeah. Gives me errors, but that's okay. Vertical hole count 3. So, yeah, so we need to like put in all these different things. So like so like horizontal hole count is equal to 5. Vertical hole count is equal to 3. So this is for like, yeah, but it'll be like local to the project folder. So what I'm gonna do is I'll have a Python file that's like start.py. I'll create a folder, create a new folder. So this would be like a new, this would be like the BP, this would be like BP Octane. Gosh dang it, I can't. Then I'd paste it in, and then I'd double click, and then I would double click on the file, and it would generate a starter file. Like it would generate a template. And then in that template would be that environment file, and I would fill it out. Yeah, I'm not really gonna be too concerned with it. If it has issues, then if I have issues with it, I'll just change it to a JSON. Vertical hole count. We want the top. What is that parameter? Because it dictates what standoff height, front and back standoff height. So front standoff height. So that would be 10. Back standoff height 20. So that would dictate, this would dictate like what I need to pack, because let's say if my keyboard, so like for some keyboards, I would use like an 18 millimeter standoff back height. Like if it's a smaller board, I might adjust the, like here, like if I'll show you, I think it'll actually come through here. Like if I change this parameter from, oh, the back is actually 18 right now. So if I change this to like 25, you'll see it like it grows. It probably will break. Yeah, it broke a little bit. But you can see like the angle is much, much steeper. So like if somebody had a keyboard that was like really big, we could keep the same angle. So like this would be the, but this would be the actual dimension of the hardware. So like this tube is a specific, you buy these in very specific length, like you can only get them in certain lengths. So I need my artisanal small batch organic automated. I need my artisanal small batch organic keybs, dude. That's hilarious. I like that. Thank you for the sub, Sam. I can always count on you to fund my addictions. You've already got your organic small batch artisanal organic keybs. Artisanal. So one of the reasons why we need to put this parameter in is because let's say there's 3 vertical holes. There's a 3 vertical hole count, which currently I don't have it modeled. I couldn't really figure out how to model this. It's just complicated sometimes, and it's like not worth it. Like I don't need to model this right here. But you know, this length, this distance is half the distance between, it's 14.1, like it's a 14 millimeter thing. So like you kind of have to be careful because like this actually needs to be 20 because they don't make, I don't know if they make 14 millimeter standoffs. I don't know if they make 14 millimeter standoffs, but the pack, like I need to automate, or I'd like to eventually automate kind of what, like if there's 3 hole counts, then the first one's going to be 10, then there's going to be a 15, and then there's going to be a 20 millimeter length. So like, you know, I can generate a pack list and like a guide. I have these like, these guides that tell me how to ship orders. So I could auto generate those, you know, with all this info. So I don't know. Maybe I'm getting a little ahead of myself because like this isn't, I got to do a few to figure out what I need and what I don't need. But it's just we're just kind of thinking through it, I guess. Yeah. All right. Well, I think we're good for this stream. I'm probably going to do a little bit of the circuit board design and like, cause I don't have any of really the circuit board stuff automated. So what I can do is make a template and start from there. So that's going to be the hardest part. Currently right now, until I automate that. There's processes that I could go through to do that, to get like 90% of the work done. But it's just like setting that up would be tough and take a while. Yeah, if you want some help. Yeah, I might want help. Yeah. It's tough. Like there's a big balance between like how much do you do, like how much does it actually save time? And it's also not only saving time, but you also want to make sure that you're consistent and you don't make mistakes. So that's also very important, is not making mistakes. So I think what I need to do is I need to do a few of them kind of semi-automated, semi-manual to figure out what I like, what I don't like. and then figure out like how my projects need to be set up, like the project folder structure and all that jazz, and then we can go from there. So yeah, let's end the stream here. We're going to yeah, we'll stream next week hopefully if I've got time. But thank you all for joining me in this wonderful adventure of parametric keyboard design. I hope you learned some new things today. I'm gonna go play Helldivers with Sam now. So I will see you guys